So the bicarbonate levels are low. And so before the compensation kicks in, it's very easy to see that this is a metabolic acidosis because the pH is low, right? And a low pH is an acidotic change. And HCO3 being a base is low, and too little of a base in the blood is also an acidotic change, right? So this, right, which is metabolically controlled, is obviously causing this. Okay? Now, when we look at the compensation, and of course this is going to be compensated by the respiratory system because the metabolic system is not available. When this gets compensated, it's a little bit less obvious who is causing the acidosis because both PCO2 and HCO3 are not within normal limits. Okay? But when the compensation kicks in, the pH rises. Okay? The pH is going to rise because the PCO2 is going to go down. It goes from normal to going down. And the way your body does that, it removes excess CO2 or removes CO2 by blowing it off, by increasing respiration. So the respiratory rate in this person might be slightly high. So the CO2 is low, and CO2 produces acid. So having less acid is an alkalotic change, right? And that makes sense because it's compensating for an acidosis change. Okay? And then HCO3 is still low because the system causing the HCO3 is still malfunctioning. So if the only information you got was the compensated numbers, okay, what this would look like is you would get a patient with a pH, let's say that's acidotic, so it would be an acidotic pH. The PCO2 would look low, and the HCO3 would look low. Okay. Now, a PCO2 being low means less acid, which is actually an alkalotic change. Now, an alkalotic change is the opposite to the pH, which is an acidic change. So it's abnormal, but it's in the opposite direction of the pH, which you know then that this is the compensation. Okay? And the HCO3 being low is an acidotic change, which matches the pH, and so you know this is the cause. So if HCO3 is the cause, then it has to be metabolic, and since the pH was low, it's an acidosis, so metabolic acidosis. And the other thing you know about this is that there's some compensation because PCO3 is low. Okay, so there's some compensation going on. A similar situation happens with metabolic alkalosis, so pH is high. PCO2 is still normal because this is a metabolic problem. But in this case, with alkalosis, HCO3 is high. Right? HCO3 is a base. It's high, it's causing the alkalosis. When the compensation kicks in, the pH goes down. Okay? It's high and it goes down as a compensation. PCO3 increases, right? We're holding on to CO2 to compensate for the pH. And HCO3 is still high because that's causing the problem. So you can see with the metabolic acidosis and alkalosis, it's the respiratory system and the change in PCO2 that's actually bringing about the compensation. In the respiratory acidosis versus alkalosis, the situation is opposite. So respiratory acidosis, pH is low. PCO2 at the start is high, producing more acid, causing the acidosis. HCO3 at the start is normal. When it kicks in, when the compensation kicks in, the compensation tries to bring the pH, increase the pH. The PCO2 is still high because it's causing the problem. And now with the compensation, HCO3 has increased, right? HCO3 is a base. It's opposite the disturbance, so it is compensating for it. Okay? Respiratory alkalosis, pH is high, PCO2 is low, right? Where we have too little CO2, too little carbonic acid. HCO3 is normal at the start. The compensation kicks in to try to bring the pH down a little bit. PCO2 is still low because it's causing the problem. And HCO3 now goes down, right? We reduce our base in order to compensate for the pH. Okay? So when you are evaluating acid base, you pay particular attention to the first three ABG or arterial blood gas values. So ABG stands for arterial blood gas analysis. So you're going to pay attention to the first three on this list: the pH, the PCO2, and the HCO3. Okay? Now, I recommend committing these to memory. So it's not too complicated. So the pH normal range, 735 to 745, and memorize the range, okay? This is just one possible point, normal point, within this normal range. So memorize that pH normal range, 7.35 to 7.45, PCO2, 35 to 45, HCO3, 21 to 28, okay? Just memorize those ranges. So let's do a practice problem, okay? And there's some steps we're going to follow. So in this practice problem, we're given this ABG data. pH is 7.31, CO2 or PCO2 is 50 millimeters of mercury, and HCO3 is 22. Okay? Now, the options that were given, okay, is respiratory acidosis uncompensated, okay, respiratory alkalosis partially compensated. That means that there's been some compensation, but the pH is still within an abnormal range. Okay, that's why it's partial. Metabolic acidosis fully compensated, which means that the compensation brings the pH within the normal range. Okay? Metabolic alkalosis uncompensated. Okay, those are our options. So step one, and when we look at these values, evaluate the pH. Is the pH within the normal range? If not, is it acidic or is it alkalotic? So normal pH is 7.35 to 7.45. So 7.31 is below the range, which means it's an acidotic change. Okay? So we know we're dealing with an acidosis. Step two, evaluate the CO2. And remember that CO2 leads to the production of carbonic acid. So if the CO2 is high, that is an acidotic change. If the CO2 is low, then it is a basic change. Okay? And the CO2 levels will be linked to the respiratory system. So let's see, evaluate the CO2. Normal CO2 levels is 35 to 45. CO2 here is 50. So that's high. So a high CO2 is an acidotic change. Okay? Now evaluate HCO3. HCO3, normal range is 21 to 28. So HCO3 is within the normal range right now. So HCO3 is a base, So if the base is high, if HCO3 is high, that's a basic change. If HCO3 is low, it's an acidic change. And if HCO3 will be linked to the metabolic system. Okay? So what we found was CO2 levels were high, which is an acidotic change. HCO3 levels are normal. Okay? Now, so step 4 is try to match the change in CO2 or HCO3 to the change in pH. Whichever matches the change in pH is the cause. All right? And if there's a change in the other value, the mismatch is the compensation. So in this example, we had one abnormal CO2 and a normal HCO3. And the pH was acidotic. CO2 change was high, which means that's an acidotic change, and that matches the pH change. Okay, so the pH is acidotic, the change in CO2 is acidotic. So now we already know, since that matches, that the problem is respiratory. This is a respiratory acidosis. Okay? Now the question is there any compensation? Since HCO3 is normal, then there is not any compensation. Okay? So this is a respiratory acidosis uncompensated. Respiratory acidosis uncompensated. That's A. All right? So if CO2 and HCO3, if one is abnormal and one is normal, then it's pretty straightforward. There's no compensation, and the abnormal value is going to end up matching the pH, okay, and it's the cause. If both CO2 and HCO3 are abnormal, then one change is going to match the pH, that's the cause. The other change is going to not match the pH, and that's going to be the compensation. Okay. So both abnormal, you have compensation going on. Now, if the pH is abnormal, and if all three values are abnormal, you know there's compensation. It has to be partial compensation because the pH is not within the normal range. Okay. And then the cause of so you know it's partially compensated, but the cause of the pH change is going to be caused by the change in CO2 or HCO3 that matches the pH. Okay? So let's do one more example and we'll see this again. So step 1 was evaluate the pH, which pH is 7.46. Normal is 7.35 to 7.45. So this pH is abnormal and it's alkalotic. Okay? The next is evaluate the CO2. Normal CO2, 35 to 45. CO2 here is 32. CO2 is low. A low CO2 is a basic change. Okay? Now we already can see that the basic change in CO2 matches this basic pH. So we already actually can say that this is a respiratory alkalosis. Let's look at whether the other value is normal or abnormal, so whether there's been some compensation. Okay. HCO3 is 23. Normal HCO3 is 21 to 28. So this HCO3 is normal. So there isn't any compensation. So this is a respiratory alkalosis uncompensated, okay, which is choice D. All right. Now if this was, if the HCO3 was abnormal, okay, it would have to be, if there was some compensation here, let's say we wanted to say this was we wanted to convert these values to turn it into a partially compensated respiratory alkalosis, then that would mean that the HCO3 would be abnormal in the acidotic direction. Okay? And what makes HCO3, a change in HCO3 acidotic, is if it's too low. So if this was 20, instead of 23, then what you could say is that this HCO3 is a base, it's below the normal range, so it's an acidotic change which is opposite to the pH. So that would make it a respiratory alkalosis partially compensated. Okay? But since HCO3 is normal, we know that it is an uncompensated problem. Okay? So keep practicing, keep reviewing, and these problems will become second nature.